today's lesson is lesson 3.2, angles and parallel lines. We talked about several different angle pairs when we have a transversal that crosses two or more lines, but special things happen when our angle relationships when those two lines that are cut by a transversal are parallel. So when our lines are parallel, such as P and Q, so right now P is parallel to Q, and the way we know that P is parallel to Q is we can look for the little symbols that mean parallel. So these little triangles, anytime you see these little triangles, that means that those two lines are parallel to each other. So if you don't see those, you must see a statement stating that those two lines are parallel. Otherwise, we cannot assume that they're parallel. So when those two lines are parallel and they're cut by a transversal, special things happen with our angle relationships. So the first thing is we're going to look at corresponding angles. So recall corresponding angles are angles that are in the same position, but they are in different groupings. So for instance, angle 1 and angle 5 are corresponding. Also, we have angle 2 and angle 6 are corresponding. Angle 3 and angle 7 are corresponding. And then angle 4 and angle 8. So when those two lines are parallel and they're cut by a transversal, we can conclude that the corresponding angles are congruent. Congruent means they measure the same. So since angle 1 and angle 5 were corresponding, that means they are congruent or they measure the same. Likewise, since angles 2 and angle 6 were corresponding, we can say that they are congruent or equal to each other. And the same thing with angle 3 and 7 and 4 and 8. So when those two lines are parallel, our corresponding angles are congruent. And that is our corresponding angles postulate. So if we look at these examples, you will notice in example 1A that we do have two parallel lines. We see the lovely triangles on our line A and B, and we see that angle 1 is a corresponding angle to that angle that measures 107. They are in the same location, they are just in different groupings. So if this angle down here is 107 degrees, since angle 1 is a corresponding angle to that one, and our lines are parallel, then angle 1 is also 107 degrees. Example B, we see that the lines are still parallel because we see the triangles. And then we do notice that the 49-degree angle is corresponding to angle 5. They are in the same location, just in a different group. So if the angle that is touching line A is 49 degrees, then that means the measure of angle 5 also has to be 49 degrees using that corresponding angles postulate. We also have the alternate interior angles theorem. So again, when our two parallel lines, if they're parallel, as long as they're parallel, if they're cut by a transversal, then something happens with our alternate interior angles. So we're going to real quickly alternate interior review. That means they come from the inside, but they're also on the alternate sides or the opposite sides of the transversal. So angle 3 comes from inside my parallel lines. And then alternate means I want the angle catty corner and on the opposite side of my transversal T. So 3 and 6 are alternate interior angles, and 4 and 5 are alternate interior angles. And so just like the last one, if the lines are parallel, then the alternate interior angles are congruent. So that means that angle 3 is the same measure as angle 6 because they're congruent. And also 4 and 5 are congruent, so they are the same measure as well. So in example 2A, we're trying to find the measure of PQR. So if we're talking about PQR, remember when we name angles, we start at P, we go to Q, which is our vertex, and then we go to R. So we're talking about finding the measure of this angle right here. And you can see that that angle and angle QRS, those are alternate interior angles. Since those are alternate interior angles, and because we see that these two lines are parallel, we know that alternate interior angles are congruent. So that means the angle PQR is going to be 35 degrees. Then we have here, we're still trying to find PQR. So we're still trying to find this angle right here, PQR. We see that it is an alternate interior angle to this angle right here. Since those are alternate interior angles and our lines are parallel, we know that those angles are congruent or they measure the same. So that means that PQR also has to be 120 degrees. A third angle pair we talked about were the alternate exterior angles. So our alternate exterior angles theorem is very similar. We're going to review what alternate exterior angles are real quick. So alternate exterior angles means they come from the outside. So angle 1 is on the outside of my parallel lines. And then alternate means I want the one that is on the opposite side of the transversal in catty corner. So angle 1 and 8 are alternate exterior angles. And then we also have angle 2 and angle 7. And so in the alternate exterior angles theorem, just like our previous two theorems, if we read through that, it says if two parallel lines are cut by a transversal, then the alternate exterior angles are congruent. So my alternate exterior angles measure the same. So angle 1 and angle 8 are congruent, so they measure the same. And angle 2 and angle 7 are congruent, so they measure the same. For example 3a, we're finding the measure of angle 1 and the measure of angle 2. So we're going to start off with the angle that we know, which is the angle that measures 124 degrees. And so I'm going to ask myself, do I know another angle relationship in this picture? And I do. Angle 1 is an alternate exterior angle to angle 124. They're both on the outside, but they're on the opposite side of the transversal. And we just learned that alternate exterior angles are congruent. So if my one angle is 124, that means angle 1 is also 124 degrees. Then I have to look at angle 2, and there are two ways to look at angle 2. So I know that angle 1 is 124 degrees. And I'm looking for another angle relationship, and I actually have two ways to look at this. We learned in a previous chapter that these two angles are known as vertical angles, and we know that vertical angles are congruent. So that means angle 2 is also 124 degrees. However, if you don't remember about vertical angles, we do know that my 124 degree angle and angle 2 are corresponding angles. And that was our first postulate, which said corresponding angles are congruent. So you can also do it that way. And then B. B, we still have a set of parallel lines, so we're still in good shape. So I'm going to ask myself, do I know an angle relationship that relates the 75 degree angle to angle 1 or angle 2? And I do. Angle 2 is an alternate exterior angle to the 75 degree angle. Alternate exterior angles are congruent, and so angle 2 is 75 degrees. Now, the 75 degree angle and the angle 1 don't have a special angle relationship. They are both on the outside, but they're on the same side, and we do not have consecutive exterior angles. So what we do know, though, from a previous chapter, is that angle 1 and angle 2 form a straight angle. So in other words, remember we said that angle 1 and angle 2 then would be called a linear pair. And in a previous unit, we learned that linear pairs were supplementary. So that means that those two angles are going to add to be 180 degrees. So if we know that angle 2 is 75 degrees, to find angle 1, we are going to subtract 75 from our 180. And so we're looking at 105 degrees for angle 1. So that one we did have to use prior knowledge from a previous unit. And then our last theorem is the consecutive interior angles theorem. And remember, our consecutive interior angles means they both come from the inside. And so we're talking about angle 4. And then consecutive means they come from the same side. So angle 4 and 6 are consecutive interior angles. And angles 3 and angle 5 are consecutive interior angles. So again, when those two lines are parallel and they're cut by a transversal, this time though, this is different. Our consecutive interior angles are not congruent. They are supplementary. So that means that those angles add to be 180. So the measure of angle 3 and 5, they are not equal to each other. They actually add to be 180. And then angle 4 and angle 6, since those are consecutive interior, those would add to be 180. So the consecutive interior angles are the only ones that are not congruent. They are actually supplementary. So for example 4, if I'm finding angle 2, we see that our lines are parallel, so we're in good shape. But we also see that these are consecutive interior angles. And so since they're consecutive interior angles, they should add to be 180. So since I already know this angle is 122, to find the measure of angle 2, I can take 180 minus 122. And so we're looking at 58 degrees for angle 2. And then we do have two angles to find for example B. In example B, I do see that angle 1 and the 95-degree angle are consecutive interior angles. So that means that they are going to add to be 180. So if I'm going to find angle 1, I'm going to take my 180 minus 95, and that's going to give me 85 degrees. So that means that angle 1 is 85 degrees. I have two ways to look at angle 2, but I think the easiest way is to look at the 95-degree angle and angle 2. Those are alternate interior angles, and we know alternate interior angles are congruent, so angle 2 is also 95 degrees. So now we're going to take those theorems and we're actually going to apply them and use some algebra to solve for x. So for the next several examples, we're finding the value of x and stating the postulate or theorem used. So in example A, we're going to ask ourselves, what type of angle pair relationship do I have? Because we see that these lines are parallel. And if we look at these two angles, those are alternate interior angles. They come from the inside and they are on opposite sides. So I'm going to use the alternate interior angles theorem, which says that those two angles are equal. Since they are equal, that's exactly what we're going to do. We're going to set them equal to each other. So I'm going to set my x plus 35. It is equal or congruent to 120 degrees. And then we get to solve for x. So to solve for x, we simply subtract 35. And so in this case, x is 85. If we look at B, again, we have our two parallel lines, so we're ready to go. So I'm going to ask myself what type of angle relationship exists between those two angles. And they are corresponding. They are in the same location. They are just in a different group. So I'm using the corresponding angles postulate. And we know that corresponding angles are congruent, which means they are the same. Since they're the same, that means they are equal to each other. And so then I'm just going to set them equal and solve for x. So to undo subtracting 30, I'm going to add 30 to both sides, and x is equivalent to 150. For example C, I still have parallel lines, so I'm good to go. And these two angles, the 78-degree angle and the x minus 2, those come from the inside. So they are interior angles, and they come from the same side. So those are consecutive. So I have consecutive interior angles. Theorem is what I'm using. And that one does not say they are congruent. This is the one that is different. Consecutive interior angles are supplementary. So since they're supplementary, that means they add to be 180. So I know that if I take x minus 2 and I add that to the 78 degrees, I should get 180. And so we're going to combine like terms first. Negative 2 plus 78 would be 76. And then we're going to solve for x and undo the addition with subtraction. And so we're looking at x being 104. Example D, when we're looking at those two angles, we know we're ready to go because we see that the lines are parallel. And these two angles happen to be corresponding, so we are going to be using the corresponding angles postulate because they are in the same location, just a different grouping. And the corresponding angles postulate says that those two angles are congruent, which means they are equal to each other. So that means that 3x minus 15 is equal to 2x plus 7. And then we're going to solve the equation for x. Now in this case, we do have to get all our x's on one side. So I'm going to subtract 2x from both sides. And then I can isolate x or get x by itself by undoing the subtraction with addition. And so we're looking at x equaling 22. And then for our last two examples, letter E, both of those come from the inside, but they're on opposite sides. So those are called alternate, and they are alternate interior angles. So we're going to use our alternate interior angles theorem. And our alternate interior angles theorem says that since those two lines are parallel, that those two angles are congruent, which means they are equal to each other. So those two angles are equal to each other. So again, I need to take all my x's to one side. So I'm going to subtract 5x. And then I need to take all my constants to the other side. So I'm going to add 34. And I get 3x equals 36. We'll divide by 3, and x is 12. I would like for you to pause the video and try letter F on your own. All right, welcome back. We're going to look at those angle pairs, and if we look at those angle pairs, they are alternate exterior angles. And so alternate exterior angles theorem says that those alternate exterior angles are congruent. So since they are congruent, that means they measure the exact same. So we get to set 14x minus 2 equal to 110. We're going to undo subtraction with addition. And then we would divide by 14. And we would end up with x equals 8. And that's how we use the theorems and postulates learned today.